everyone, I'm Heather. I'm an OpenSciEd teacher and facilitator, and I'm excited to provide you with an overview of Lesson 4 of the Weather Unit. This lesson's fun for students because it's really hands-on, and students not only get to do the investigation, but they also get to help plan it out as well, which really helps give them more ownership of what we're doing as scientists and why we're doing it. So let's get started. How did we get here? During the last lesson, we figured out that regardless of the season, the temperature of the air is always decreasing as you move further and further away from the Earth's surface and higher into the atmosphere. The air temperature at those high altitudes is coldest in the winter, and when the temperature of the air is increasing, the speed of the molecules that make up the air is also increasing, and the opposite is true when the temperatures are decreasing. That means that the molecules are moving slower as well. In this lesson, we're wondering, how does the air at the surface gain more energy than the air further away from the surface? I mean, after all, isn't this coming in contact with the sun first? Shouldn't it be absorbing more? But it isn't. We want to investigate how and why that is. So our lesson at a glance, we're looking at 2.5 days for this investigation, about 15 minutes of prep on your end for this hands-on investigation. I would suggest using this guidance on using the light sensors video. It's linked in the materials section of the teacher guide for lesson 4. It's embedded down inside the digital version of the lesson guide. And it really kind of helps you visualize like what we're using the light sensors for in this lesson before you go ahead and like try to help students plan it through. So like I said, day 1, we're really looking at a game plan here, helping the students come up with a game plan on how to investigate our question. How are we going to test it out? Coming up with a plan that we agree on. By day 2, we are then going ahead and conducting that investigation that we planned out on day 1 and trying to make sense of our data. Through our data analysis, we figure out that surfaces on the ground are absorbing or reflecting different amounts of energy. This absorption or reflection of the sun's energy is also affecting that temperature right above the ground. So we want to model that and explain that in day 3, which is set to be a half day, but especially your first time through will probably take you a full period. What we're really trying to come to consensus on here is that as particles at the surface absorb that energy, they're moving more and can touch other particles near them, like the air particles that are right above the surface. Particles have to touch in order for energy to flow from the surface to that air above. And as the air particles touch other air particles, they might be able to spread that energy up and away from the surface as they collide as well. So putting it all together, what we figure out is that the energy from the sun is absorbed by the ground, which then increases kinetic energy and therefore temperature of the particles in the ground. Different ground surfaces heat up differently depending on how much energy from the sun is absorbed, which could be impacted like type of material, color, those kinds of things. But depending on the amount of energy that the sun is absorbing, that's going to affect things above it as well. As air particles come into contact with the ground, energy is transferred to those particles through conduction. And on a sunny day, the air temperatures above the ground are still cooler than the air than the ground itself. It's always going to be hotter at the surface. Even on a super hot day, it's still a little cooler right above the surface. So key moments that we want to keep an eye on here. Part 2 is just planning out that investigation. One thing that I suggest doing is having light meters and thermometers and even a meter stick out, which meter stick isn't mentioned in the lesson guide, but we found it really helpful so that we controlled our distance away from the surfaces that we were investigating. But we want to get the students to think about like, what is our question that we're trying to answer, and identify the question that we plan to investigate by practicing putting an independent and dependent variable into that question. We want to work with partners and small groups to kind of plan out in those boxes that you see in the handout. What do we plan to do with things? And then come to consensus in the science circle on a plan for tomorrow's investigation. And I like to make a digital copy of that handout so that we can kind of scribe that together and revise that plan together in the scientist circle so we have a solid plan moving into the next day. As we conduct the investigation, it's a good idea to perhaps have a template prepared for a data table. What I ended up doing was just taking the sample data from one of the other handouts that was in the folder. I just cleared it all out and then used that as a template that we labeled together before we collected the data, just kind of as a review for here's what we're collecting data on today and here's how we're doing it. So then we have that data table ready to go and it's pretty efficient. Part 7, reporting the results and making sense of data. We're bringing our data back up to the science circle and looking for patterns, and make sure that you also have a good solid idea of like what those key ideas are that we're looking for, so that you can kind of guide those questions to help them get to that point. And those are listed on the lesson guide on page 1 and 2. You'll see where it says key ideas that we figure out. And we want to pull those ideas out from the patterns that we see. One other thing we might want to think about doing here is creating like an exit ticket. There isn't one in this stuff, but or in the folders, but if you create one that looks kind of like a blank template of the picture that you see here at the bottom, and let them maybe fill in what the particles are doing as like an exit ticket, or even an entry assignment. So that way, when they come to the science circle, that we can come to consensus. We have some ideas on what we're thinking is happening to those particles when the surface is absorbing the energy, and what's happening to the air right above it. So they're coming to the scientist circle with some ideas. Part 10, developing that consensus model. Students should be bringing those ideas, like I mentioned, either from the exit ticket or entry assignment, whichever you decided to do. Again, it's not in the plan, but I would give it a go. And that way they have some solid ideas that they're bringing to the scientist circle to help make this model together and consensus ideas. I would also suggest you making the model first and like planning out some of those back pocket questions that you're going to ask to make sure that you get all those key ideas pulled out and onto the model and within the progress tracker itself. Where do we go from here? By the end of lesson 4, we should be able to explain why the ground and the air near it heat up, but what happens to the air near the ground once it's heated? Does that energy just stay at the surface? We know that heat rises, but how does it? That's where we're going next. So we want to figure out we know that heat rises, but how does it do that? So some material management tips and tricks, like I mentioned, for the planning of the investigation, having that set of materials out and visible when students are preparing and planning the investigation really helps them visualize what we have that we can use, and then maybe think of a sensible way to collect data with these things to help us answer our question. Another thing that I really like about OpenSciEd resources is that they're editable. And if you need to tweak something a little bit, you can. Like, there wasn't a blank data table, but you could easily make one so that makes that data collecting much more efficient. Practicing your consensus models on your own first, and making sure that you're adding like some ideas for questions down that you might ask students. Just having that ready. Half the time it's like making your grocery list, right? Like, as long as you wrote it down, you kind of remember it. So just even having that there as a reminder of like what I need to ask students in the moment is super helpful. I've already kind of thought it through. And use that teacher guide to help you come up with those ideas or help you kind of practice how you might model it. And that also helps you to avoid any rabbit holes discussions and things like that. So I definitely suggest doing that first. And if you do have some rabbit hole questions that come up, perhaps asking students to write that down on another sticky note so that you can add that up to the driving question board. Might help you later on. Our word wall management, there are just a few words from lesson 6.1 or from unit 6.1 and 6.2. You can see those over here: incoming light, absorbed, conduction, lux. These are all words that they know from previous units, but we're just kind of bringing them back to the surface. Poster management, again, a consensus model we're creating of the incoming light and the energy absorption by matter near the surface through conduction and particle contact. That's that model that they were using on their exit ticket, and then we came to consensus on at the end. We're making that. We can probably do that up on a chart paper poster to keep that visible so that we have that idea in the back of our mind moving forward. And as always, keeping the driving question board and investigation ideas visible is always helpful. My students really liked this lesson because they got to plan and carry out an investigation that was very hands-on. And you'll probably notice too that the more they get to do the investigations, the more engaged they are. I hope this video helps you think about some key things that you can try as you help do this with your students. And I thank you for watching, and I'll see you in the lesson 5 video.